Starting with the third problem of cycloid. A circle of diameter 50 mm rolls without slip on a horizontal surface by half a revolution, and then it rolls up on a vertical surface by another half a revolution. Draw the locus of point P, which is initially at the bottom of the circle. Now compared to the previous two problems, that circle was rolling along a straight line for one complete revolution. But here the motion is divided into two parts, that one complete revolution. For first half revolution, it is rolling along the horizontal surface, and then for remaining half a revolution, it is rolling along vertical wall. So the solution will be different compared to the first two. So first half a revolution is along the horizontal surface. So for half of the solution, we can follow the same procedure as that of the previous two problems. So for that, initially we will mark the directing line, and remember here after half a revolution we need to go along vertical wall. Okay, so we need to start at the bottom so that for remaining half a revolution we can go upwards. Okay, so suppose if I start from here, so again the same procedure, marking the perpendicular and drawing the diameter of the circle to mark the initial position, because initially it is rolling along horizontal surface. So we'll assume that the circle will roll towards right. Okay, so the diameter is 50, so I'll mark the diameter length of 50 mm along this vertical line. So I'll first mark 50 mm length, and then the center is 25 mm. So now I can draw the initial position of the circle. So radius is 25. Okay, so yeah, 50 mm. So this is the center C. Now we need to divide the circle into some equal number of parts. Since the diameter is again less 50 mm, we will go for 8 number of parts instead of 12 parts. So the first few steps will be similar to the previous two problems. So we will just do it. Dividing the circle into 8 parts. So just I need to mark 45, 45. So I'll just rush through these steps because we have already done these steps in previous two problems. So no need to explain again. I'm just dividing the circle into 8 parts. Again, first I need to locate the initial position of point P. It is said that draw the locus of point P, which is initially at the bottom of the circle. Bottom of the circle means initial position of P is here. So again I'll start naming 1, 2, 3, 4, 5, 6, 7, and obviously 8 will coincide with P. Now on the horizontal surface the circle is going to roll for half a revolution only. So I'm going to mark only half of the circumference length, which is, so if I calculate pi d distance, that is the total circumference, which will be 50 into 3.14, which will give me 157, and if I exactly divide by 2, I'll get 78.5. Okay, so I can take approximately 79 mm because it is not possible to take in decimals. So for half a revolution I'll take distance equal to 79, somewhere here. Okay, and half a revolution, that means it will be fourth division, so I can name this as 4 dash. So here, after half a revolution, I need to again locate the position of a circle. So again, drawing the diameter 50 mm perpendicular. So first I need to mark the perpendicular. Why there is need to draw the circle, position of a circle after half a revolution? I'll explain you that, because many of you do the mistake of drawing the position of wall. So after half a revolution, the new position of center will be here. Okay, so I'll taking again 25 mm radius and drawing the circle position after half a revolution. Okay, now distance from P to 4 dash is half of the circumference, which is nothing but 79 mm. So I'll mark this distance as pi d by 2. Okay, so this 79.5 is nothing but pi d by 2 distance. Okay, so this pi d by 2 is 79 mm. Now after half a revolution, this is the position of circle, but for remaining half a revolution it is going to roll on vertical surface. So obviously that vertical surface should be in contact with the circle and not passing through the center line. Many of the students do the mistake of drawing the vertical surface on which it is going to roll for remaining half a revolution from the center line itself, which is wrong, because after half a revolution this is the position of circle, and for further rotation the position of vertical surface will be tangent to the circle. So this will be the vertical surface. Okay, so this, to this pi d by 2 I need to add this distance, which is r, radius of the circle. Okay, now we'll follow the same method for first half a revolution, that is drawing horizontal lines. First, from the center of the circle, I'll mark the new position of the centers for half a revolution along the horizontal center line. So from this center line I need to project. So again I need to divide this P dash 4 dash. Now here we need to divide only into 4 equal parts, not 8, because we are considering only half a revolution. So we'll again follow the acute angle method. 4 equal divisions, 1, 2, 3 and 4. Now joining the last division and drawing the parallel lines to that. So be careful while drawing the parallel lines, because many a times this roller gets tilted. Okay, so after marking the first division I can carry forward the same equal distance for remaining divisions. So your last division should coincide with P. So here I am getting exact divisions. Okay, now I'll name those divisions as 1 dash, 2 dash, 3 dash and 4 dash is already marked. So from 1 dash I'll draw perpendicular up to the center line to mark new position of a center C1, then C2, C3 and C4 is already marked. So I'll name this as C1, C2, C3 and C4. Now next step is drawing the horizontal lines from each division. So one is here on the circle. So from each division on the circle I need to draw horizontal lines. So for first division it will pass through 1 and 7. Second division obviously passing to the center line. Third division, third and fifth horizontal line, and then the topmost 4. Okay. Now for half a revolution we need to mark first 4 points. So starting with C to P, the distance is radius in compass. Now with C1 I need to mark the new position of P, which will be P1, will be this point P1. You have to immediately name the point. Then C2 on the horizontal line, because it will move upwards. Then this will be P2. Then with C3 here, so it will be P3. And with C4, the point will be the exact topmost point on the circle. It will become tangent. So P4. So now I can join the arc for first half a revolution by smooth curve. So initially joining by light line up to P4. So I can make it dark now. Okay. So after half a revolution, the position of center for the circle is C4. Okay. Now for next half a revolution, it is going to follow vertical path. So the center, new position of center C5 will be along this center line. So I have to produce this vertical center line. Okay. Now to get those new positions of centers C5 to C8, I need to mark the remaining divisions. So 4 divisions we have already marked on a horizontal line. So now the point of contact with the center, the circle with the vertical wall is this. So corresponding to this point, center C4, I can again start with 4. Okay. Now I have to mark the remaining 4 divisions, which is 79 mm. The total distance will be 79 mm, which I have to divide into 4 equal parts. Now for divisions, no need to again follow the acute method angle here. I can take the same divisions from the horizontal line. Okay. And I can mark the remaining divisions 5, 6, 7 and last is 8. Okay. So these points will give me the new positions of centers along the vertical center line. So I can drop the perpendiculars. So that means perpendicular to the horizontal center line from each point. So from 5 I'll get new position on a vertical line C5. From 6 we can locate C6. From 7 C7, and from 8 the final position of the center C8. So this will give me new position C5, C6, C7 and C8 along the vertical center line. Now we can draw the final position of the circle after half a revolution along vertical line. So this will be the final position of circle. Okay. Now we need to draw the horizontal lines from the equal divisions marked on the circle. So these divisions we already carry forward from this horizontal projectors. So now we need to draw vertical divisions, vertical lines from those divisions. The center line is already marked, so this line should be parallel, and then the tangent. Okay. Now from C4 we have located P4. When the circle will start rolling along the vertical wall, from C5 we need to locate new position of P5. Again, for that I have to take the distance equal to the radius, which is already taken in the compass. So with C5 I need to cut the arc. Now I need to decide on which line should I cut. I have two options: one division towards right of the center line, because with C4 we have already cut on the center line. Now with C5 I need to either cut one division towards right or one division towards left, but this will depend on the nature of path followed by point P after half a revolution. So obviously when circle is rolling along the wall, P4 will go down. Instead of moving up, it will go down. So this will be the exact position for P5. Now after reaching C6, I'll get a tangent point at 6. That means that point P will exactly touch the wall, so it will become tangent here. That wall will be the tangent to the circle. So P6 is the tangent point. So the nature of curve from P5 to P6, so from P4, P5, P6, if I join, it will be somewhat like this. So it has touched the wall. Now it can't go further on the right hand side, so it has to come back on left hand side. So with C7 I need to cut the arc on left hand side. So I'll come one division towards left from 6, so I'll get somewhere here, and remaining with C8 I'll mark P8 on the center line, so one division further more, so which will be the final position on the circle here. So this will be P7 and this last point is P8, or we can say P dash. So now for joining P6 to P7 to P dash, I'll again draw by a smooth curve. It is not a straight line but a smooth curve, so the nature will be somewhat like this. Okay, so this is the actual path followed by the cycloid. P to P4, that is the usual we have done for first two problems. Then P4 to P6, touching the vertical wall, then again leaving the vertical wall. So the final position will be P dash here. Okay, so this completes the solution for this problem.